parallel and perpendicular lines, which may be something that you recognize from your Algebra 1 class. So typically I would have you do this warm-up on your own, but since I'm doing a video, I'll do this warm-up with you. We're going to calculate the slope of each line, and we'll write the slope next to each line. So to start, the first line, you'll notice this line from here to here has a rise and a run, and it has a positive slope. You should remember this from Algebra 1. You move up 1, 2, 3 units, and you move to the right 1, 2, 3, 4 units. Up 3, right 4. So we would say that the slope is 3 over 4. In the second line, you'll notice they give us 2 points. We're going to use these 2 points. And we can go up 3 and run 4. And again, our slope is going to be 3 over 4. What do you notice about these 2 lines? These 2 lines are what are called parallel lines, and there's something special about the slopes. These slopes are the same. They are equal to each other. So we're going to record that the parallel slope property says that the slopes of parallel lines are equal. They have to have the exact same slope, so that way the 2 lines never intersect each other. Now look at the next set of lines. In the next set of lines, I'm going to do the blue line first. You'll notice they give us this point and this point, and we're going to rise. It looks like we're going to rise 1, 2, 3, 4, 5 units. And we're going to run 1, 2, 3, 4, 5, 6 units. So this first slope has a positive 5, 6 slope. The slope is positive 5 over 6. You'll notice that it goes in the same direction as these other slopes. So if you pay attention here, look at this green mark. This slope is positive. This slope is positive. This slope is positive. They all run in the exact same direction. As opposed to this slope, which should not be positive, this slope should be negative. So you'll notice on this line, they give us this point again and this point down here. And if you count and go straight down, you will notice that you go down a total of 6 units, and you go right a total of 5 units. So we go down 6 and right 5. Since we're going down 6, we're going to put a negative on there, and therefore my slope is negative 6 over 5. Now these slopes are a little different when you compare them. Take a look at this number, 5 over 6 and negative 6 over 5. They are not the same, but they are very similar. What do you notice about 5 over 6 as compared to negative 6 over 5? You should notice 2 things. They have opposite signs, and they're also flipped. The numerator and denominator are flipped. Those are called opposite reciprocals. So for perpendicular slopes, slopes of perpendicular lines are opposite signs and reciprocals. Take a minute to write down that perpendicular slope property. And I want to go back to the picture, and I want to make sure we know why these these lines are perpendicular. Do you see the box they gave us in here? These 2 lines are perpendicular lines. They intersect to form a 90-degree angle. Therefore, we know that these slopes are not going to be the same like parallel, but their relationship is opposite reciprocal. Just some examples of opposite reciprocal, just so you can recognize. If I gave you 3/4, the opposite reciprocal would be -4/3, comma. If I gave you -1/2, the opposite reciprocal would be +2/1. If I gave you, let's say I gave you a slope of 4, that opposite reciprocal would be -1/4. Don't forget, this is really 4/1, okay? And when you reciprocate 4/1, you get 1/4. Another weird one you should know is what's the opposite reciprocal of, for instance, -1? The opposite reciprocal of -1 would be positive, but it'd be 1/1. It's actually itself. Remember that this 1 can be written over 1, and so its reciprocal, flip the numerator denominator, will also be 1. Now, for today's lesson, you need to know what's called the slope formula. This should be another formula that's very familiar from Algebra 1. The slope between 2 points x1, comma, y1, and x2, comma, y2 is calculated using m equals y2 minus y1 over x2 minus x1. Hopefully that formula looks familiar from what you might have studied back in 8th grade. Hopefully this is very familiar, or in 9th grade Algebra 1. Okay, this is a formula that's been used a lot in algebra, and we're going to need it in the rest of our lesson today because we're going to be comparing slopes to determine if lines are parallel, perpendicular, or neither. Let me show you how we're going to use this formula. Take a look at example 1. Consider these points, C, D, E, and F, and they give us all of the coordinate pairs for these points listed out very nicely. We're going to determine, is CD parallel to EF? So first, we're going to look at these points CD, and we're going to calculate the slope of CD, this line CD between these 2 points. So we'll start with the slope of CD. M will equal, you subtract the y coordinates, 3 minus 2, and then you subtract the x coordinates, 8 minus 5. So I did first, just to show you, I did 3 minus 2. That was this top part, 3 minus 2. And then the bottom part, I did 8 minus 5. That's your run. I'm doing 8, take away 5. So that way you know exactly where that's coming from. So 3 minus 2 is 1, and 8 minus 5 is 3. That's the slope of CD. Now we have to calculate the slope of EF. So now we're doing the exact same thing. We're going to calculate the slope. M equals, we'll subtract the x's. Subtract the y's. When we subtract the y's, I'll color code this for you. Here are your y values, 5 minus 8. And then we're going to put that over, and then we'll subtract the x values. I'll color code that for you as well. Our color code here is going to be -6 minus 3. So we'll simplify and see what we get. You can use a calculator if you need to. 5 minus 8 is -3, and -6 minus 3 is 9, which reduces down to give me a positive 3 over 9. The two negatives cancel, which then reduces to 1 over 3. Now we compare these slopes. What do you notice? These slopes are the same. So therefore, these lines are parallel. So we will conclusion, CD is parallel to EF because the slopes are equal. Okay, you've got to calculate both slopes and then compare, are they equal to each other? Now look at example 2. Consider 3 of these points. We're going to now look at A, B, and B, C. Are they, remember this symbol? This symbol right here means perpendicular. So first we'll study AB. Slope of AB. Okay, so AB, our slope is going to equal 4 minus 2 is in the numerator. Those are the x's. I'm sorry, those are the y's. Those are the y's. And then 3 minus 1 is in the denominator. 4 minus 2 is 2. 3 minus 1 is 2. And we get an answer of 1. Now we have to calculate the slope of BC. You have to use points B and C now. So M is going to equal, for B and C, I'm going to underline those 2 points I'm going to use. We'll do 2 minus 4 over, and then we have to do 5 minus 3. 2 minus 4 is negative 2. 5 minus 3 is 2, and that gives me negative 1. What do you notice about these two slopes? They are opposite signs, but they are also reciprocals. If I take 1 over 1 and form its reciprocal, it also gives me 1 over 1. These reciprocals are the only time when the reciprocals are the same. So since the slopes are opposite reciprocal, here's our conclusion. Our conclusion is that AB is perpendicular to BC because the slopes are opposite signs and reciprocals. Now let's move on to example 3. Consider points A, B, C, and D. We want to determine now finally A, B, and C, D. Are they parallel? Are they perpendicular? Or are they neither? Okay, so here we go. We're going to calculate the slope of AB using the slope formula. So start with A and B. M equals, we subtract the x's, or the y's first. The y's go on the top. So 8 minus a negative 6 over, and then we do the y's. The x's are, I said that backwards again. The x's are 6 minus a negative 15. So remember, it's always y's on the top. I want to show you exactly where this is coming from. I did 8 minus negative 6, 8 minus negative 6, and then I did the x's on the bottom, 6 minus a negative 15, 6 minus a negative 15. So these double negatives will give me nice positive 14 on the top. And in the numerator, it looks like I have 21. And if you simplify 14 over 21, you get 2/3. Divide by 7 gives you 2/3. Now let's do the slope of CD. M equals, okay, now we're going to do C and D. We'll do the y's on top first. 10 minus negative 2 goes on top. And then the bottom are the change in x's. Negative 4 minus 4. Let me show you the matchup again. 10 minus negative 2. 10 minus negative 2. order does matter. You have to go in the proper order. Then you go -4 minus 4. That's this bottom part right here. Remember, you have to go in the same direction. So 10 minus -2, -4 minus 4. Okay, you have to always go in that same direction, same direction. Okay, can't mix it up. You should remember that from Algebra 1. Now I end up with a 12 on the top, and on the bottom, I end up with a -8. And if you reduce this, divide by 4 on top and bottom, you get 3 over -2. Now we compare, and what do you notice about these slopes? These slopes are not the same. They are opposite reciprocals of each other. They're flipped, and the signs are opposite. So our conclusion will be is that AB is perpendicular to CD. Okay, they're perpendicular lines. Finally, I have one last example, example 4. Given points E, F, and Q, find the coordinates of P such that PQ is parallel to EF. So let me plot these points first. Point E is at -3, 0. This is point E. Plot that point for me first. Check, that one's done. Point F is at 5, -4. 1, 2, 3, 4, 5. 1, 2, 3, 4. This is point F. And then point Q is at 4, 2. So 1, 2, 3, 4, 1, 2. This point right here is 4, 2. Now, we want to know what point do we need. Oh, I forgot to label that point. That last point was Q. Okay, so make sure I've got all my points labeled. Okay, this point is Q. You don't need to put the coordinates there if you don't want to. So our goal is to find PQ to make a parallel to EF. First, why don't we go ahead and calculate? Why don't we go ahead and make a line through EF? This is EF. So we have to figure out where is point Q. We want the lines to be parallel. If the lines are going to be parallel, we need to have the same slope in order to be parallel. So we have to calculate a slope on that line EF. So basic slope calculation shows that you are going to rise 1, 2, 3, 1, 2, 3, 4 units, you rise. And then you run to the left, 1, 2, 3, 4, 5, 6, 7, 8. You run to the left 8 units. This should have a negative slope. It's very important it has a negative slope because we fall backwards on this particular line. This line goes down. So our slope of the first line is going to be rise 4 over -8. Now, you can leave this the same slope if you want, okay? Or you can simplify it down, and you could say this slope is just the same as -1 over 2. So when we go to our next line to find this point Q to make a parallel line, we're going to do the exact same thing. You need to rise 1, 2, 3, 4, and then we're going to run 1, 2, 3, 4, 5, 6, 7, 8, and this should be your point. So that way, when I connect this point with point P, we should get some nice parallel lines. So this line is definitely parallel to that line. So what is point P? Point P is going to be the coordinate pair. It looks like -4, 6. -4, 6 in order to get those parallel lines. Okay? Now, you're going to start on a homework assignment, but just as a little homework helper, flip to question 4 on the homework, and I just want to help you real quick get question 4, 5, and 6 set up. in questions 4 through 6, you have to find the slope of each side of each quadrilateral, and then we'll figure out, is the quadrilateral a trapezoid or a parallelogram or a rectangle, or just an ordinary quadrilateral. So I just want to make sure you can calculate these slopes with ease from Algebra 1. I hope you remember. Okay, so for instance, if I'm going to do this side first, here's all I want you to do in this assignment. If I want you to do this side first, I want you to figure out that slope. So you're going to rise 1, 2, 3, 4. Is that 4 units? I can't even tell. Let me try that again. Rise 1, 2, 3, 4, and then you're going to run. It looks like 1, 2, 3. Sorry, it's very hard for me to count a grid on here. So this side is 4 over 3. That makes this slope is 4/3. Okay? Now, when you do your other one, the other side, some of them are going to be negative. Make sure you know which one's a negative slope. So like this one right here is going to be down 1, 2, 3, and you're going to run 1, 2, 3, I believe, right? Down 3 and run, oh, that's 4. That's 4. Okay, so therefore, this is going to be a slope of, since I went down 4 and I ran 3, this will be a slope of negative 4/3. Nope, I did that backwards. Negative 3/4 is that side. So you could probably say that those sides are perpendicular to each other. Okay, they're probably going to form a nice 90-degree angle. You're going to calculate the rest of your slopes. Don't forget, you got to do this one, you do this one, and then tell me what kind of shape you think it is based off the definitions of those quadrilaterals. Okay? That's your goal. That's just a little homework helper to get started. You will now finish the rest of this homework page and then take a picture of all 3 pages and submit it to Schoology. If you do not submit your work to Schoology, you will not get credit for today's work. That's all I have for you today. Have a good day.